Hello, guys. Welcome back to Maths Zone African Motives. We are still on our revisions, working on our grade 12 mathematics, and this is part of our derivatives, which is our differential calculus that we're going to work on, the differential calculus. So the section also includes the polynomials, all right? But in our class for today, we are going to actually consider the average gradient and the rate of change, these two. We need to focus on these two. Then as time goes on, you're going to see that we're going to dual match on our differential calculus and also not forgetting the polynomials. So I'm not going to waste your time, guys. Quickly going through this first part, we have already discussed the basics of the average gradient. Remember, in your grade 10, grade 11 mathematics, you had the condition where you dealt with the gradient given a certain function, all right? Let us say we are given a function, any function. From the given function, you are going to realize that the average gradient can be obtained when given 2 points. It is the average gradient taken between two given points, all right? Between 2 points. Let's say I've got point A and point B. These two can be used to determine what we are referring to as the average gradient. All right, the average gradient. Remember, before you dealt with the gradient, that is the same thing, but only that it's from a curve, it's from a function where you must be given 2 points. Previously, you were just given determine the gradient between the 2 points, 5, 3, and another point, maybe 7, 1 like this. Given these 2 points, you're going to determine the gradient. You were already given the points. So it is just a continuation from that part that you're given before. Only that you are the one to determine these points from a certain function. Let's say y is equal to 3x squared. Then you're being asked to determine or to calculate the average gradient between the points where x is equal to 1 and x is equal to 3, like this. These are the 2 points. I mean, these are the values of x that you're given. From these values of x, you must obtain the y values so that you have got what you call a point. Remember, a point, you must have the x and y value. Once you have that, you can determine your gradient. So I'm not going to waste your time. Like I said, let me quickly go back to what we do understand. Remember before, we said the gradient of any given function, all right? It is a linear function or whatever that you're given. It is taken from M, which is actually from a straight line. When you're given a straight line, when it is on a curve, that will be a tangent to the given curve. So let's say I've got a straight line like this. You're going to need a point and another point. Given these 2 points, one of these points will be called x1, y1. The second one is going to be x2, y2. These are the 2 points that you are referring to. So we've got point 1, x1, y1. Point 2, the x value is going to be x2, y is going to be y2 because it's second point. So the average or the gradient in basic consideration is taken from the change in y over the change that happens in X. So the change in Y is simply the difference between these 2 points. So you're going to need Y2 minus Y1. All right, so it's going to be Y2 minus Y1. That is the change in Y. Or it can be given as Y1 minus Y2 over the change in X, the X values, the difference between the X values. So if you start with this denotion of a 2, you must also consider X2, X2 minus X1. If you, let's say you started with a 1 here, Y1, therefore here it must be X1, 1, 1, take note, 2, 2, this must correspond, 1, 1 like that. They must correspond. All right. Do not interchange the formula. So choose the formula properly. All right. The one that you're going to use. Any of these two formulas, you are going to obtain the same value for the gradient. So M simply represents what? The gradient. Remember, from the equation of a straight line, y is equal to mx plus c. We said M represents what? The gradient. This is the same M that you are calculating. So if you are given a straight line y is equal to 2x plus 3, there is no need of determining the gradient using the formula because already you can take it from here, the what? The coefficient of x. So it means your gradient M in this case is going to be equal to 2, the coefficient of what? Of x. So this formula is used when you are given points, first point and the second point. When you are given what? Points, that is where you can use the formula. Given the equation of a straight line, you can easily tell the gradient is equal to this, all right? So when I have a function like this, any given function, is it a cubic, whatever function that you're given, the gradient, which is the steepness of the slope, changes from one point to another, from this point to this point to this point to this. So you find out, all right, the function will be increasing, going up. Then the function is now decreasing, going down. The function is increasing, going up. The gradient is differing from one point to another. So the average gradient, you must have what? 2 points, all right? In order for you to determine the average gradient, you are going to need what? You will need 2 points. So this issue of the grammar, guys, just pardon my grammar. Use the one that you understand in a better way. You know, mathematics and English, they are so parallel. So you will need what? 2 points in order for you to determine the average gradient. Then apply what? The formula. Like I was saying, on a given function, the gradient is going to be changing from this point, another point, like that, like that. It will be changing. The gradient that you use from these 2 points is the difference from these 2 points is the difference, like that, all right? So in our case, we are working with 2 points. We are going to have another calculation of the gradient, which is taken at a single point, each point, not 2 points, at a single point. So that will be one of the other classes that you're going to have later on. So when you are given 2 points, you can determine your average gradient. I hope we are together on this part. So let me give you an example where we are going to calculate our average gradient. All right, let's say we are asked to calculate the average gradient. All right, let me just put it here. Calculate the what? The average gradient. The average gradient of the function right, y is equal to 5x squared minus 4. All right, between between x is equal to 4, let's use minus 4 and x is equal to -1. These are the values of x. This is an example. Like I said, all right, you do understand from your grade 11 mathematics when you dealt with functions. This is a quadratic. All right, I'm not answering the question right now. I just want you to understand what you're dealing with here. It's a quadratic, and the coefficient of x squared is what? Is a positive, like this. So we're going to have our graph being concave up, facing up, something like this. So you find out that when the graph is like this, it is going down. That's a decrease from here to here. It's actually going down as the values of x are increasing. All right. The y values will be actually going down up to a certain point where there is no change that is happening at a stationary point. Then from this point, the graph is now going up, or the function is now going up. So here it was a negative, here it was a positive. So this is the condition that will happen on a quadratic or on a parabola in a basic view. So you'll be having your x values like this one, -4, up to -1, in between. Then you're going to say, okay, this graph is increasing or not. All right, this graph is increasing or not. If it is increasing, then we are going to notice that it is going actually up. The increase part is going up in terms of the graph. We can notice from the graph. But in terms of the gradient, you will notice that it is going to be steeper like this, facing up. And these ones that are having a line or a tangent of this nature, they are always positive in terms of what? The gradient. So in our case, our gradient must be what? Must be positive. When it is going down, the gradient is going to be what? Is going to be negative. So those are the conditions that you're going to be actually facing in calculations. So I'm just gonna have this question quickly. All right. So now I'm explaining other things. So to elaborate more, let me have this question like this, all right? So that we can understand it better, like this one. All right. This is the question that I just gave you. It was on the first part to determine the average gradient of the graph, all right, between x is equal to -4 and x is equal to -1. So like I said, in order for you to determine the average gradient, which we are going to use the letter m, is simply the change in y over the change in what? Over the change in x, y2 minus y1 over x2 minus x1. So as you can see, x1, y1, it's a point, meaning to say from the x value that you're given as your first point, you're going to find the y value. So take note, you already have the equation or the statement where y is taken from x. From where? From x. Y is equal to what? 5x squared minus 4. From the value of x that you're given, you can find the y value by substituting that value of x where you see x here. You substitute, you put that value of what? Of x. That is the condition, just like that. So let's consider when x is what? -4. That is the first value of x. All right. When x is equal to -4. You can even start with this one when x is -1. Not a problem. It's not a problem. So from there, you're going to determine the y value. Y is equal to what? 5x squared. From here, from that equation, put x here. In place of x, put what? -4. So that's 5 into -4 squared. Minus what? -4. This is part of your equation, this one. So you have to just write as it is. So y is going to be equal to what? All right, using this calculator, 5, open bracket, put -4, close the bracket, square it, and subtract 4. So this is 76. So y is going to be 76. That's a point. Where x is -4, y is this. When this is -4, when. So we have a point x versus the value of y. So that's we've got point -4, the y value being what? 76. It's now a point. Since this is our first point, we are just going to call it x1, y1. So we do the same thing. When our x is what? This time -1, just like when we had -4. This time our x is -1. So that is the condition when x is equal to -1. All right, let's put that in our equation. Y is equal to 5. Our x is what? -1. So in place of that, you put -1, or I can just put this one like this, -1 squared. That part is being what? Squared, -4. So that's you and your calculator this time. Just put -1 in place of that -4. You're going to put -1. So y is equal to what? 1. So that's a point. -1, y is what? Y is equal to 1. So we have a point, and the second point is what? X -1. What about the y value? It's 1. So these two can give us the average gradient. Because we said it is from what? From the formula. So with the formula, guys, look what is missing. So those x values helps us to determine the y values. So we have got 2 points. Like I said, the average gradient is taken from what? From 2 points. So the second point, we're going to call it what? X2, y2. So let us use our formula to determine our average gradient. What is the value of y2? Y2 is equal to 1. Substitute that. Minus y1. Y1 is what? 76. So that's -76 over what? We're going to need the value of x2, which is what? -1 minus x1. X1 is -4. So we're going to need a bracket for that. All right, minus what? -4. Just put it in a bracket like this. So guys, the calculator is going to simplify everything. Let us have our calculator. Put a fraction, 1 minus what? 76 over -1 minus, then you open the bracket as it is here. You put a negative, this one, -4 like this. So that was gonna give us -25. Just like that. So we have the average gradient from the given information. So do not worry about these questions. Just do revise the basics. All right, just the basics as I am having it right now. So without wasting your time, let us consider the second part of our question, which is part B. On part B, is the function increasing or decreasing between those x values that were given before, -4 and x is what? -1. Is it increasing or decreasing? All right, let's go back here on this information that I was actually explaining here. The increase or a decrease of a function can be actually seen if you have got the graph or the function there properly drawn. You can notice from that. But in this case, we do not have it's not drawn, guys. We have its properties. So in between -4 and -1, what is it that we have? We have got the -25, which represents our average what? Our average gradient. Can this help us to tell whether the function at that condition is increasing or not? Yes, the gradient can help us. Remember, if m is negative, that's what? A decrease that you have. If m is positive, that's what? An increase that you have. So in our case, we have got what? In our case, our gradient is negative. So that's a decrease. The gradient here that we calculated, all right, let's go back here. The gradient is what? Negative. So negative gradient, that's what? That's a decrease. So the function is what? Is decreasing at that point. The function is what? Is decreasing. So this is the condition that is happening between what? Between x is equal to -4 and x is equal to -1. X is equal to -1. In between that condition, the function is actually what? Is actually decreasing because we have what? Because we have a negative gradient. If it was a positive gradient, we're going to be having what? An increase or a positive gradient, just like that. All right. So let us have another question. Here we are given calculate the average gradient of the curve f of x is equal to this, all right, between these values of x. So guys, just like before, we can see that it is the same, our f of x, it is the same as just writing y is equal to. So y is equal to x into x plus 3. Yes, you can even expand that one. X times x is going to be x squared. X times 3 is going to be what? 3x. It is up to you, or you can just even substitute your values in this equation as it is. So let us consider, like I said, the average gradient, you're going to need 2 points. So when x is what? Positive 5. Let us substitute. Therefore, y is equal to what? You substitute in this equation or you substitute in this one. It is up to you. If you are using this one, it is going to be 5 squared. Our x is what? 5. You can even open a bracket if you want, but the positive value, no problem. 3x, 3x. In place of x, you put what? 5 again. Or you're just going to substitute here as it is. In place of x, you put a 5. Here you put a 5 again in place of what? In place of x, you put the value of x, which is what? Which is 5. So either way, you're going to obtain the same answer, 5, open bracket, 5 plus 3, that is equal to 40. All right, let's see from this one. 5 squared plus 3 times 5. This is 40 again. So you can see that you're going to simply have the same value of y. So that's a point that you now have. When x is 5, y is what? Y is 40. So that's a point, x1, y1, since this is our first point. The second point is when x is what? When x is 3. When x is equal to 3, you do the same thing. In place of x, you're going to put a 3. So that's 3 squared plus, in place of x, you're going to put a 3. 3 times 3. So using your calculator, guys, you were going to obtain positive 18. So that's another point. When x is what? 3, y is 18. So we are going to take this as our second point. So as this is our second point, it means we're going to have x2 and y2. Therefore, using our formula to determine the average gradient where m is equal to y2 minus y1, the change in y over what? Over the change in x, x2 minus x1. We are going to determine our gradient. Y2 is what? 18 minus y1, which is 14 over x2, that is 3, minus x1, our x1, which is what? Which is 5. So this was going to give us the average gradient of 11, right? Then on part B, the question is now, what can you deduce about the function f between x is equal to 5? Between x is equal to 5, the same x that we had before, and x is equal to 3, the same condition that we had before here, the same values of x that we used to calculate the gradient. But we are asked to say, what is it that we can say about that gradient when the gradient is positive, taken between 2 points like this? It means it is an increasing, the function is increasing between those two given points. It is actually going up where the gradient is what? Where the gradient is positive. So at that moment, our function is what? Our function is increasing. So here we can say the function is actually what? Increasing. Is increasing. All right? Between those values of x. Between x is equal to what? X is equal to 5 and x is equal to 3, just like that. So that is increasing because the gradient is what? Positive. When the gradient was negative, like what we saw here, it means between the values of x, at that moment, that function was what? Decreasing. So that is the condition of an increase and a decrease. You take it straight as it is. All right. So guys, for the first part, I think it's actually fine on the average gradient. This is going to lead us to the average rate of change, which is also another section, very, very important just for you to understand the average rate of change. So I also want you guys to do as many questions as you can. Preparation is very, very important. Do not wait for exam time. Do revise all the basics. All right. So when you refer to the rate of change, it is simply a condition that is the same as the average gradient. The rate of change or the average rate of change between 2 points on a graph is the average gradient. It is the same. If you're given 2 points on a graph, point A and point B. So maybe it's we are referring to the distance time graph, where distance is given in terms of what? In terms of time. All right. So the same thing, by having 2 points, substituting the values of t, which represents what? Which represents the time, you obtain the values of s. Then you use those to determine your average rate of change. So when you are referring to the distance, the average rate of change is the gradient, which is the average speed. It will be like speed, which is the change in distance, change in distance over the change in what? Over the change in time. So it's distance over the time. Change in distance over the change in what? Over the change in time. This is average speed in actual sense. So average values, they are taken. We are going to consider much about that in terms of the applications of derivatives. But for now, I just want you to know the basics, all right? We are going to dwell much about this one later on as we consider our derivatives or our differential calculus. So we need to say, for now, I just want you to have the basics. As an individual, you must have what? The basics. All right, let's consider a graph of this nature. Let's say this is representing distance and time. This is our time here in seconds, and let's say this is our distance, which is in meters, all right? Then you are being asked from the graph that you are given, find the average rate of change between A and B, or find the average what? The average speed. The average speed between points, all right? Let us just say between A and B, because they are, well, no problem. You can just use them as points between A and what? A and B. The average speed, it is because you've got distance and time, not given not given to say this is distance or this is time. Let's say we're not given that. They will just say the average rate of change. It is the same average speed when you are dealing with the distance and what and time. So for you to have that average speed, guys, it is the same. I said here, average rate of change, when we are to describe it, it is the same as what? As the average gradient. Remember, I said that? It is the same as what? As the average gradient. So meaning to say, I just need 2 points, just like before. So when you're already given those 2 points, A and B, what you need is to know, okay, what is the X value at A? Our X is 1, and Y value is what? Is 3. So you take time as like this is the X-axis, the distance, this is the Y-axis. So you'll be having X, which is representing our time. This is our time in seconds, all right? But you're just taking it as the X value, 1 versus 3. So you remember you start with X followed by what? The Y value. And another one that is at B, we're going to take as our second point. What is the value of X there? It is 3. And the value of Y, taking the Y-axis, is what? Is 27. So you have all the points just like before. When you say this is your first point, this is your second point, so Y1 minus is the same thing that we had before. It is the average rate of change. So if you are using X values to say this is X1, Y1, this is X2, Y2. So you're going to call M Y2 minus Y1 over X2 minus X1. If you are using in terms of time, as you can see, time represents what? Your X values. Maybe you're gonna write T and S for distance using the letter S. It's gonna be T1 T versus S, T1 S1. Guys, this is up to you. If you want that, just use X and Y, the one that you're used to. Then you can determine your what? Your average gradient. So Y2 is 27 minus Y1, which is 3, over X2, which is 3, minus X1, which is 1. That was going to give us the value of what? Of our average speed. If you are referring to the distance time graph, it will be called what? Average speed in meters per second. So that was going to give us 12 meters per second. If it is gradient, let's say they said calculate the average gradient or the rate of change. You are not given the units, you are not given like this is distance, this is time, just write 12. But here we are focusing on the average what speed. So it is measured in meters per second, distance over time. Remember we said it's distance over what? Over time. So our distance in meters, our time in seconds, meters per second. All right. So that is the basic idea actually of what you're going to need in your calculation. All right. That is the basic idea that you're going to need. So I want you to work out the basics. Like I said, we are going to dual match on what we are having. We are going to add more information from this. But for now, that is it. That is it. Just go through all the basics, and we are going to add as we are moving on. with our topic. All right, as we are moving on with our derivatives, it's going to be a lot. So our next class is going to be on limits. Limits. So make sure you follow up the playlist, guys. All right, we are going to dwell on limits as our next class. So you follow the playlist. Very, very important, all right? From the first video up to the last one, so that you understand the whole topic, including question papers as part of what? As part of your revision. Where you do not understand, do not hesitate to ask questions. The comment section is there. The community is also there. We can use that one to communicate where we do not understand. And also not forgetting to join membership for more explanations, for more classes where you need direct interpretation, or I mean like direct explanation on a certain part or a certain topic. Join membership so that we can have discussions as we move on. But for now, that is it till we meet again.